Okay, so what we're going to do today is we're going to start where we left off, and then after I'm done with two different examples, then I'm going to I'll grade the homework and we'll work on the rest of the class and I'll try to give you a hand if you need it. All right. If the projector turns on. So last time, we were going through and talking about setting up our objects to draw, setting up WebGL. So again, this is one of the more tedious steps of this class, getting it started, but a lot of it we can reuse. So now this portion, when we actually get to the individual elements that we're drawing, you're going to have to be a little bit responsible because some of it is you're going to have to make on your own. Now, the lucky part about this is even this we can reuse a lot of what we do here because until we get the textures, we're just going to be using X, Y, Z, and RGB values. So it's not, luckily for you, you won't really have to change how we read our attributes in. Unless you want to create your own buffer, if you if you want to create your own normal buffer. Some people did that last semester, but you don't have to. So, but this part is going to change or could change a little bit based on what object you are rendering. So, as you recall, kind of going along with our theme of OOC, we want to create all of the things we draw, all of it, say the entity as we draw, we want to have in a class. And this is going to be useful, as you'll see very quickly, because we can start applying properties to our entity that we couldn't otherwise not, such as location, rotation. If it's a game, we have health, etc. So we very quickly will take advantage of the OOC-ness of this. So here, just as a reminder, we have to create the buffer, and then we have to tell GL what buffer we're going to modify. Now remember, this is kind of like a state machine, so it's just like I'm setting the color in the 2D draw. Once I set the buffer, it will be that buffer until I set it to a different buffer. This is very important because it can actually mess with your program if you're not careful. So I set what buffer we're going to modify, which is the buffer we just created, and then I set the vertices, which right now is just going to be X, Y, Z, and then I'm going to buffer data. So I'm going to say, okay, we're buffering data, and here's the values of our vertices. Remember, we have to cast to a float 32 array because JavaScript does everything in doubles, and all graphics engines, to my knowledge, use floats. I have not encountered one that does not. I'm not saying it doesn't exist, but I have not encountered it. And for this class, we can use GL static draw. So this will store the information to this buffer. So and we made a big deal about it last time. This is a very costly step in general. In this particular example, it's not so bad. We have 3 points, nine floats. That would be the end all. But as your vertices get larger, your objects get larger, this becomes a very, very costly step, and we only want to do it once. So, after we have that set up, now, finally, after we've gone through the entire WebGL interface.js, we've gone through the entire setting up the web page. Now, finally, we can go to the render function and try to render this picture. I just thought of something. I want to make sure that JavaScript's not. Let me do this here. Okay, good. It is. All right. Yeah. So, like I said before, we're going to set this up in kind of a pattern. So we're going to say all of our classes are going to have a render function that we're going to draw, and this will render it to the screen. And again, that allows our main loop not to worry about the particulars. We just let each individual class deal with how to render itself. So this at first seems kind of strange, and it probably seems like dark sorcery, which happens now. But the first thing we have to do, we have to kind of go back to our shaders now at this point, is now we're passing information into the shader, or we're going to tell the shader rather how to read the buffer. That's a better way of putting it. We've loaded the data in the buffer, and now we've got to explain to the shader, how do I read this data? So if we go back to our shader, and we are going to kind of ignore the fragmentation shader right now, Fragment Shader. But if we look at the Vertex Shader, we are going to have we have this attribute, a vector4, and it's a _position. And actually, I think this should be a vector3, but because we're passing in. But I made it a vector4 because GL position expects a vector4. So it will actually work in this case. Remember, the attribute in the GLSL represents the thing being passed in from the buffer. So we now have to tell the shader how to read in these data values and populate the set attributes here. So that's what we're kind of going to do now. How many people in programming 1 did the string parser in C++? Where you had to move the pointer across the string, and get to the new substring? Okay. So you're kind of doing the same thing right now. If you've ever done that exercise, it's similar to that, except it's floating point numbers. So the first thing we have to do, and this is why we have to pass in the program. Remember, we made that variable program, and it said this is the thing we're kind of looking for. And so we passed it into the render functions in our main function. I'll show you in a moment. So we passed in that program, and now we have to say we need essentially a pointer to the attribute we want to populate in the GLSL program. And so we have position attribute location, and with gl.getAttributeLocation, what program we're using, and then the name of our attribute, which if you remember right, was a_position, and that is the attribute we're going to try to populate. That is our pointer to what we're trying, explain how to populate that attribute from the buffer. And you don't actually have to do this step here, but you could. This can actually happen right here, actually. So this does not have to happen here. But this is basically saying, okay, by the way, I don't know what else is run, so we are going to use my buffer for our data. So we're going to do bind buffer again. Now, this does not, the reason I do this is because I don't know what else is run. Something else may have bound to a different buffer, and I don't want to actually accidentally draw someone else's buffer. I want to draw the buffer for this object, so I have to rebind it. But I am not doing buffer data. So I'm switching back to the buffer that I made in my constructor, but I am not doing buffer data. Does that make sense? Is that clear? So buffer data is the bad one. If I did a buffer data here, I would end up having a lot of latency. But I'm not doing buffer data. I'm just switching back to the buffer that I created in the constructor. Again, This line could actually go down here. Doesn't go anywhere. So the next thing we're going to do is we're going to set a couple variables. You can do it this way, or the version on the video, he calls the vertex attribute pointer function and splits it out like this. But this is just an easy way to kind of visualize it. We're going to state how big or how many values are in a single vertex. We're going to say what type they are, GL float. It's not going to be normalized. I think everything here is not going to be normalized, so we'll just keep this as false, or don't normalize the data rather, so just keep this as false. We're going to set the stride as 0. That means it's the that there will be stride move forward size. That's actually. Oh, wait, no, I went that. So stride is 0 because we don't have any offset. So remember, in vertices, we have to think beyond just coordinate points. You're going to have other things in coordinate points besides other things in vertices besides coordinate points. And the stride, it says, like, if you need to, how many more do you need to move until you get to the next vertice. So this is the number of components we're trying to get for this particular attribute. It is not necessarily the number of components we need to get to the next vertice. In this case, it is. So our stride is 0. But we'll see soon that we have to change this when we add color. Because like the only thing we have is the 3 coordinate points right now. And the offset of where does our particular data we're looking for starts at 0. So this will make more sense, I think, when we hit the color part, but this is just to explain what's happening, is I'm telling WebGL how to read in the buffer data. The buffer data itself is just a set of bytes. It doesn't even know it's a floating point values. So if I just start streaming out a bunch of floating point values to you, it means nothing. Same thing with the graphics card. So this is explaining what's happening, saying, okay, I'm going to grab 3 floats, I'm not going to normalize it, and then I don't have to jump to get to the next, vertice, and I don't have to offset in case to skip values for the next vertice, so the very next value will be the next coordinate. That's what this is saying. I think it'll make a little bit more sense when we hit the color, when we add color to it. Any questions with that? Okay, we'll come back again. We're going to hit this again. So I'm going to enable vertex attribute array, and I have to enable it, pass in the pointer I found up here to my attribute to enable it. Then I've got to pass in for a vertex attribute pointer, and yes, it is actually attribute pointer. That's not a typo. These different parameters in this order. So we have position, the pointer that we found, the size, the type, normalize, and then stride and offset. Now, normally I don't ask syntax questions on a midterm or a final or quiz, but these questions in particular are valid. So anything in this constructor and anything in this render function are valid. And I think it will make more sense why I do that, because you'll be using these quite a bit. So it is necessary that you understand what's happening there. So just understand that, and we'll talk about that when the midterm comes up, but this is a valid syntactical question group I could ask. So once I've set that, now the graphics card knows how to read the floating point values coming from my buffer. Does that make sense? Yeah? Yes?
So in this context, buffer is the frame being.
Buffer is essentially just my vertices at the moment.
Okay.
Or, well, it is my vertices. It's essentially just my coordinates.
In your binding,
It's right here.
in your binding them because you define them, so then you're setting that as the instructions.
Yes. So in a constructor, I create the buffer, and then say, okay, I'm modifying this buffer, then I pass these vertices into it, and then I've written values to it. Then, in the render function, I'm going to rebind that buffer saying, okay, because I don't know what else has happened. Someone else, or another program could have bound to a different buffer. So I'm going to bind to my buffer again. And then I'm going to find the attributes in my program and explain to the GPU how to read in those values I gave to my buffer. So that's what's happening here. It's just explaining to the GPU how to interpret those numbers I gave. After that, I can actually do the draw. And so I can use primitive type. I'm going to do GL triangles. So what does GL triangles do?
Draws triangles.
Okay, so I have 6 points. How many triangles do I get?
2.
Good job. All right. We're paying attention. So I have GL triangles. Then I have the offset of how many vertices I want to offset, which in this case is 0. And I have 3 vertices, so my count is 3. And then I can say, okay, GL draw arrays, the primitive type, which is the GL triangles, the offset, which is 0, and the count, which is 3. And I will render all 3 vertices. And because it's GL triangles, it will create a filled triangle. So, I save it, I run it. Oh, and the other thing I did too is down here I made a new class, which is literally the same exact class, except I changed the vertices. So I didn't really do anything special here, except I just changed the vertices on it, which is kind of dumb, but.
So you did everything the exact same.
I'm sorry, what?
Everything's the exact same.
Yeah, except that the vertices were different. Now, before going back to my main HTML, I create my first triangle. I create my second triangle. Now notice, if I've created my second triangle, that means I actually have bound to a different buffer now. I now have a different set of vertices for my triangle somewhere else. And so when I do t1.render, it's really important that I've bound back to my own buffer. Otherwise, I'm going to be drawing the other triangle's vertices. If that makes sense. So here, this is an example of why it's so important to make sure you are currently using the correct buffer. Think of it as a state machine, just like we do color or font size. We have to make sure we're currently using our buffer. So if I go back to my class, I have my constructor, I create my buffer, bind it, load the data. Then I call the other constructor, I create a new buffer, bind to that new buffer, load the data. Then I go back to my first class and call render. If I did not do this line here, then I would be rendering the previous buffer, the buffer from the second triangle. Does that make sense? We'll come back to the attribute pointer stuff. This will make sense in a minute, but we'll come back to that. Don't panic too much about that. Question?
So to get to run HTML, I don't think we went through.
Okay, so we didn't go through main. So in main, I create the var, the WebGL interface that we talked about, and then I create 2 instances of my triangle. Oh, by the way, I include the source after my shaders. I include the source here. Actually, weirdly enough, okay, sorry. So here's my main function. I call main down here, but yeah. I call main up, and then I have two triangles, and then I render the first one, I render the second one, and I have to pass in that program variable we found with my WebGL interface, or WebGL interface. Because both of these rely on that program to set the attribute pointers. Now, it is necessary that you reset the attribute pointers for every object unless it's exactly the same object. Now, it doesn't make intuitive sense because if you have the same convention for all your shapes, so X, Y, Z, and maybe RGB, you would think that you would only have to set it once. But you do actually have to explain to OpenGL how to load in that data every time you switch to a different object. So that was one thing that when I first taught this class, it caught us off guard, and we were having some strange errors. And what happens is, as long as you have the same shape, it works. But the minute you add like a plane or a different type of shape, then things get really wonky at that point, to put in technical terms. So basically, I don't have any loop. I'm not animating. I just engage the interface, create one triangle, create a second triangle, render the first one, render the second one, and I'm done. So this is a one and done type render program. So I launch this in Chrome, and then I think, remember right, this is the first triangle, this is the second triangle, I believe. But anyway, these are my two triangles, and I'm not scaling them or anything. I literally have different vertices. And yes, I could actually modify these triangles so that they would that they could use the same set of vertices, and I could just move this one over and scale it larger if I needed to. But it's not. It's not a big deal right now. We just literally have two separate triangles, two separate vertices. Easy, right?
No.
10 pages of code. We got two triangles. Woo! All right. So, now you're probably wondering, this is really dumb. Like, let's go back to context 2D. That made way more sense. And this is stupid. Well, if we remained in the realm of 2D, I would agree with you. But since we're going to 3D, this is necessary. Again, the aspect or the silver lining to this issue of trying to get derived or to start is the fact that you can reuse pretty much everything all the way up to textures. We're going to be playing with our shaders a little bit, but as far as the interpretation of the buffer and as far as the WebGL interface, we don't really have to change anything. So that's the benefit to this. This is kind of just, say, a boilerplate code to get the system up and running. Now, so we have this thing set up here. It's nice, it's cute, but we really like to add different colors besides blue. Right, so now we're going to add some. So how do we add color, and what do we do with it? Well, the big thing we're going to change, how we want to add color to our setup. Now this is going to be a little more complex than simply adding a couple lines because we actually will affect the entire pipeline. And if you remember right, color gets set at the fragmentation shader. Right now, we're just setting everything to blue. Okay, well that's unpleasant, but I mean, so we have to modify this step here. But in order to actually modify that step, we have to be able to pass it into the Vertex Shader because that's the starting point for everything from the perspective of JavaScript. This one we just passed into here. And then this shader has to pass it into the Fragment Shader. So now we basically have to carry along all these attributes so to get to the Fragment Shader. The way we're going to do this now is we're going to start adding properties to our vectors, or to our attributes. So we're no longer going to, in our vertices, vertices. Sorry. We're going to be adding properties to our vertices so that they're no longer going to have X, Y, and Z. So right now, all we're doing is sending an X, Y, Z, and the fourth variable is 0, which is fine at the moment. But now we're going to have a new attribute, which is going to be another vector 3. It's actually going to be vector 3. And this is going to be a color, RGB. And remember, RGB for now will be, well, it has to be a float between 0 and 1. So here, RGB, blue, and the fourth value is the alpha. So the way we have to do this is we have to have a new attribute for the color itself. Okay, so you may want to pay attention to this part. We're going to have a new color, or a new attribute for color, and we're going to make this a vec3. And now, so this would be great if I was going to use it inside my Vertex Shader. I would just have to modify how I read my vertices, and then I could just send it into this function, and everything would be good. But I don't want to use it here. I want to use it down here. So I have to create a varying. And a varying is a special variable that will transfer between a Vertex Shader and to the Fragment Shader, and assign it to this color, and then have the same varying declared down here, and then I can use it in here. So it's a little bit strange. It's how it has to be done. So here I need a varying. And I completely forgot how to spell that. Shoot. Varying, yeah, it's a Y. There's a Y. I knew there was a Y. There we go. Vec3 and V underscore color. And then we're going to put this right underneath the medium float. So now, whatever I assign to this variable will be transferred to the Fragment Shader. So all that's left to do now is to say, okay, V color equals color. So now, this value will be assigned to the varying, which will then be transferred to the Fragment Shader. And then here, this is a cute trick you can do. I believe it will let me do this. V underscore color, and then comma 1 saying, okay, and we also have one more value, make it a vector 4.
Another row in
Color, yes, I know. In my world, that's how you spell color, all right? So, I don't know if this will actually render anything because I haven't set that attribute up. Let me see if it runs right now. Okay, yeah, that actually is good. So I know I don't have any syntax errors, I don't have any linker errors, but now my blue's gone away and everything's black. And the reason for that is by default this is 0, 0, 0, this color. So I know that my syntax is correct. I can't pass. I haven't set up how to pass things in yet. So again, I have a vector 3 and vector 4. Hopefully, you kind of starting to understand how these data structures work in GLSL. And I can say an attribute. I'm going to pass it in. It'll be color. I'm going to then have a varying vector 3 v color. Set my v color equal to what I passed in on the attribute, and then this will be transferred to the Fragment Shader, And the Fragment Shader will then set the frag color equal to vector 4 with this vector 3 and then a 1 added to it. So this notation is legal in GLSL, which is actually really nice, because it allows us to kind of convert between vectors fairly easy. So now, all I've got to do is try to figure out how to put values into that. That make sense? Okay. So again, since this is an attribute, we have to go and modify everything we just did with the attribute pointer. And we have to modify our vertices. Because now we're going to have more than just we're going to have more than just coordinate space here, more coordinate values. We're now going to have the colors themselves in each vertice. And remember, like I said, each vertice, the Fragment Shader by default will blend between the colors, and you get a nice gradient, if you will, for all the different colors. So I'll show you that in a moment. So, well, actually, I'll show you right now. Let's go to our triangle 1. And we're going to add some values here. So now we have x, y, z for our triangle. Let's do this. So that's x, y, z. This will be RGB, red, green, blue, red, green, blue, red, green, blue, and no comma. So JavaScript doesn't care about the white space, but this is more for you to kind of see what's happening behind the scenes here. Oh, come on. Fine. Line up my commas, maybe. There we go. So X, Y, Z, RGB. That's going to be our new way we define a vertex. So now a vertex doesn't just have 3 floating point values, it now has 6. 6 floating point values. So you see very quickly, if we added, say, other properties like texture coordinates, UV or normals to this, we could very quickly end up with over 10 floating point values per vertex. And this is why graphics start taking up a lot of memory. It's like if you ever play a game, you load up a game, you have this really high resolution textures along with high lighting effects. You watch the memory usage will increase, because every vertex of your umpteenth millionth vertex character now has 10 or 20 floating point values associated to it. Probably not 20, but close to 10. And it's going to start taking up memory very quickly. So everything in this class, I mean, we'll probably like 50 vertices might be about as far as we go for one object, but in a game, it's very common to have much, much more. So you have to remember, everything we do here, the memory and not necessarily computation, but the memory for it is going to be exponentially more when you go into like a real world setting. So now I have red, green, blue, or sorry, X, Y, Z, red, green, blue, and now I need to feed that into the this render program. So I explain to the renderer how to read this. What would happen if I ran this right now without setting to render? I mean, don't think about like what it would look like, just what would happen. How would that be interpreted, the way I have it? Yes?
Would it read the color value as like a vertex?
Yes. Very good. So each one of these, each three of these vertices or values would become a vertice. So I would end up with 2 triangles. In fact, we can test it out. It won't look like much because I think the RGB will kind of go across the screen if I remember right, but. But it disappears now. So that might be. It might be a line, yeah. So I could do this. If I make it 6, which I don't want to do, but if I make it 6, I might see something. No? Okay. So it just kind of breaks at this point. Which I think it's, I don't know why the other triangle went away. 1. Yeah, I think it is a line. Okay, so it just reads this as a line, or and doesn't render anything. So we now have to figure out what do we want to do with. That shouldn't have still worked. Did I have an error? I feel like that should have given me something. I guess not. Okay. But now we want to figure out how do we render, how do we add color to our setup here. And the way we're going to do it is we're going to basically copy what we've done so far, and we're then going to call this enable vertex on a different attribute, but this time, what's our attribute going to be named? Remember from the shader? What's the name of the attribute we're going to look for? Great, shout it out. Color. So we called it color, so that's the attribute we're gonna search for. So I don't normally recommend copy and paste, but in this case we will make an exception. And we're going to change this. So first of all, this is now going to become color. I guess I could put a underscore color if I wanted to match the convention. The size, I'm still looking for three numbers per vertice, RGB. They're going to be floating point, not normalized. Now, the stride is going to be, this is basically going to be the size of each iteration for the next position. So make sure I get this right. This would be 6. Oh, sorry, I think that, yeah, that should be 6. This, and we have to change the stride up here. That'll be 6. So we're going ahead 6 floats, and then this time the offset is going to be 3. So now with the color value, let's see. First of all, did by any chance I get that right out of the box here? Nope. Oh, so that's what I forgot. So you do have to. So you do have to take it down to bytes. So this is basically going to make sure I have everything else set correctly. Yes, yes, yes. Okay, good. So now, bless you. Now this should work. Oh, come on. Not valid operation. Offset. Oh, I forgot. Then I have to say enable vertex to. We have to define a new value, a new thing. So we'll say color attribute pointer. and we're going to enable that for that value, and we're going to set that here. Oh, the offset is also in floats. Sorry. Please wait. There we go. Sweet. Okay, I know I can make it work. And so there's our red, green, blue triangle with our nice gradients. Whew, okay. I should have known that. I'm sorry. That was silly. Okay. Now, so what's actually happening here? Now we can kind of take a moment and look at this, and it'll make a little bit more sense. We have a 1D array. I don't know what the numbers are. So 0.5, 0.5, 0.5, 0, 0, 1. And then we continue on to the next vertex. Okay? So all of this, these 6 values, these six values is one vertex. Now, if we look at the first one, we're saying the size of what we're trying to grab is 3. That means we want 3 floating point numbers. So we know we need to select 3 of them. We know that the entire thing, the entire vertex, is going to be 6 times the size of a float bytes long. So the stride and the offset are in terms of bytes. So we know, okay, so there's 6 floats altogether, and we're looking for 3 of them. And then the offset says, okay, well, we're starting at 0. So now I'm going to start at 0, or at the beginning of my location, and 0, or 1, 2, 3. These 3 values are then going to become my X, Y, Z. But I know that my stride is 6, so I'm then going to skip 3 more floating point values to get to the next vertex, to get the next X, Y, Z. Does that make sense? Whereas the color now, I'm still looking for 3 floats. I know it's size 6, but my offset is going to be 3 floats in terms of bytes, which is going to put me right here. This is the offset, the color offset. So then I get 1, 2, 3. These 3 values become the color bits for the color attribute. And then I know my offset is 6, so I'm going to skip 3 again. And then the next preceding 3 are going to become the next color. Does that make sense? What's happening? How I'm reading in these values. So it's important you understand this, because and feel free to add your own attributes. A lot of people are adding the normal attributes. I did something different because I wanted to make it easier, but you can add your own normals. You can add all sorts of things you want to attributes. You just have to make a parser to parse out how you read those attributes. You can even do logic in the shaders. It's not advised, like it's not something you want to do a lot of, but you could hypothetically even pass in and have it be one more floating point value and pass in 0 or 1, and read that into a Boolean variable on the shader and use that for a test. That's, you want to be careful with how much logic you do on the shader. It's designed for math, not logic, but you can. I mean, that's a possibility. So now that I've read that in, then this will be read through, and it will get the first three values of x, y, z, which gave me the same size triangle, and the second three values, which gave me the RGB value. Any questions? And the thing I forgot, it's good to remember, is the offset and the stride are both in terms of floats. That is that was the thing I forgot. Or terms of bytes, terms of bytes, or in terms of bytes, not floats. So it's not just a counter; it's a terms of bytes. As far as my rendering goes of this, nothing's changed. I'm still using GL triangles. My offset 0. I'm not skipping any vertices, and I have 3 vertices altogether. I now have double the information that I had before, but I still only have 3 vertices. Does that make sense?